In this section we're looking at the midpoint and distance formulas. Now before we get to those actual formulas, let's define what a midpoint is. And as it says here, the midpoint of a segment is the point that divides the segment into two congruent segments. So let's say I have segment AB here. The midpoint, which I'll call M, is the point that's in the middle of that segment. So it cuts it in two congruent parts. So I can mark congruence here for each of those parts. So we could even say that segment AM is congruent to segment MB. Now congruent is not the only thing we can say. Since they are congruent segments, we can also say that their length is the same, and that AM equals MB. And that's saying the length from A to M is the same as the length from M to B. Now even though we don't know those values, let's imagine we did. What if this was 5 inches from A to M? Since it's the exact same and that M is in the middle, we would automatically know that one's 5 inches as well, MB. Now let's kind of go with that thought a little bit more. If AM is 5, could we already know what AB would be, the whole thing? And since it's a midpoint, we know that we could double it. So that even lets us say that AM, which is still equal to MB, those are both equal to 1/2 the whole thing, which would be AB. So another thing we could use to help us out. Now a segment bisector is another term we have related to a midpoint. So let's say I still have a segment here, AB. A segment bisector could be a point, it could be a line, it could be a ray, it could be a line segment, it could even be a plane that intersects the segment at its midpoint. So we still have this midpoint M here, but this object here, whatever it may be, in this case it's a line, is the segment bisector. It cuts it in half. So there's a variety of things it could be. But the key thing we're recognizing is when we see the term segment bisector, it means we have a midpoint and we're going to solve it like the problem above. And it's just kind of two different ways you could look at it. They could tell you you have a segment AB with midpoint M, or they could tell you that you have a segment AB with a segment bisector. Both of them mean the same thing. You have a midpoint, which means you have two congruent segments. So let's look at an example here. I have point M as the midpoint of segment VW, and I need to find the length of the segment VW. Now if this was segment addition, which we talked about in the last section, you'd want to add VM and 3x plus 3 and get a total. Well, notice we don't have a total here that we could work with, so that's probably a hint that segment addition doesn't work, besides the fact it says midpoint. Now since it does say midpoint, we know that VM is equal to MW. Then we can plug in the actual values we have, 4x minus 1 and 3x plus 3. And that gives us, by solving, of course subtracting 3x from both sides gives us an x, adding 1 to both sides gives us a 4, x equals 4. Not our answer, we have to keep going. So VM, therefore, is 4 times 4 minus 1. I just substituted in 4 for x. That's 16 minus 1, or 15. Now, if that's 15, and we're thinking about a midpoint, we should know from right now that MW should also be 15. Otherwise, it's not in the middle. They're not the same. So we check, and we get MW is 3 times 4 plus 3, or 12 plus 3 gives us also 15. So in the end, we know that VW is the total of both, and it's 30 units long. Now, we talked about midpoint in a general segment. What if we had to use the formula? And this is where we're going to have coordinates, or we're going to have points on a graph. So let's say I have 2 points. We'll call them A and B. And we'll call it x1, y1 are their coordinates. And then x2, y2. And we'll put a line between and make it a segment. So the coordinates of the midpoint of a segment are the averages of the x-coordinates and the averages of the y-coordinates of the endpoints. So what we're saying here is that the midpoint I like the keyword here of averages. We take the averages of the coordinates. So if I have two x values, one from point A and one from point B, their averages if I add them together and divide by 2. If I do the same thing for the y coordinates, y1 plus y2 over 2, that's going to give me the averages of each coordinates. Now this midpoint is an actual point we'll just call xm and ym. So what are we doing here? Let's look over at our graph again. Imagine, forget the 2 dimensions here. Let's just think we're on a number line. And we got x1 and x2. I want the middle because the midpoint is in the middle. So if I add the 2 and divide by 2, I get its middle value. It's in between them both. And that could go up and hit a point. And then if I did the same thing over on y, I'd have y1 and y2. I'd have a middle value there. And that would meet out at the same point, and this gives me my midpoint xm, ym. So it does fit. It's in that middle point of the graph. It should be, if I drew a line from A to B, M would be on that line, and it would be halfway between both endpoints. Now let's try one out. Let's just pick some points here. How about 1, 2, and 7, 8? If I have 1, 2, and 7, 8, I have to first pay attention to my x values. My x values are 1 and 7. So my midpoint is going to be 1 plus 7 over 2. And then my y values, 2 plus 8 over 2. I get 8 over 2. And 10 over 2, which gives me 4, 5. 4, 5 is the middle of 1 and 7, and 2 and 8, so that is my midpoint for those 2 points. Let's look at a couple more. So how about now I have segment RS, and I want to find midpoint M. So I'm going to start with graphing this one. So I have 1, negative 3 is R, 5, 1 is S, and I want to find the point in the middle. Now, if we just kind of cheated here and drew this segment, I would notice that it goes over 4 and then up 4. Now I want the middle of that, so I could almost take half of that, go over 2 and up 2, and I'd be at this point right here, which is 3, 1, negative 1. Let's fix that, negative 1. So that looks like it's the middle. That looks like it could work on the graph. So let's check by using our midpoint formula. So our midpoint formula is going to give us the coordinates for M. I look at my x values. I have 1 plus 5 over 2. My y values, negative 3 plus 1 over 2. I get 6 over 2, negative 2 over 2, and it turns out my midpoint is in fact 3, negative 1. So I can even kind of look at the graph and cheat to make sure my answer is fitting, but my midpoint there is also 3, negative 1. Now in the second example here, it's a little bit different, and we have to be careful. We have to read the instructions. It's telling us we have segment JK with midpoint M, and then they give us 2 points M and J. Sometimes we can be really careless and say, oh, those are automatically my points, plug them in and solve. But what this one's actually saying is, you know the midpoint already, you need to find another endpoint. So if I have 2, 1 and 1, 4, try this again. 2, 1 and 1, 4 there. So we have J and M. I need to find K. Now K is not between J and M. K is the endpoint, so that M is between J and K. So right now I know K should be somewhere over there. So let's look at it two ways. Let's look at graphically first. If I'm going from J to M and then M to K, up above in that one we said we could go up 2 over 2 and repeat it itself. So I'm going to do the same thing here, but this time I go down 3 over 1. If I do the same thing again, I end up at this point. Well, let's check out that point. So let's see. It looks like it lines up with J and M, so that means it could be a possibility. It looks like where it's at, it could be make M in the middle. So why don't for right now we put a K there, and that is 3, negative 2. And let's see if it works. So to find this, I'm not going to take the two values and plug them in. I'm going to start with my midpoint. And my midpoint here is 2, 1. And that's equal to that midpoint formula. Well, I have a 1x value. I don't know the other one. That's the one I'm solving for. So I'm just going to call that x1. And then I take my y value, which is 4, and I don't know the other one, so I'm just going to call that y1. We could call them x2 and y2. It really doesn't matter. But at this point, I have to keep going to solve, and we kind of run into a roadblock here. Because we have some constants on one side and we have x's and some unknowns on the other, we got to break it apart. And if we look here, these two terms are both x values. So I could take them out and say that 2 equals 1 plus x1 over 2 and solve it by itself. That becomes 4 equals 1 plus x1, or x1 equals 3. If I look over at my graph at my possible answer for k, alright, 3 for x is looking good. Now we're going to take out the y values, and I could say now that 1 equals 4 plus y1 over 2. That becomes 2 equals 4 plus y1, and y1 is negative 2, which gives us our point is 3, negative 2. And how about that? It matches what we had. So our answer is k is the point 3, negative 2. Now we move on to distance formula. Very different thing. Midpoint gave you a point that was in the middle. There will always be a point as an answer, x-coordinate and y-coordinate. Distance formula is going to give us a length. It's a number that's going to represent how far apart the 2 points are. So let's start with a couple points. I have A, which we'll call x1, y1, and B, which is x2, y2. Now if they were just horizontal or vertical lines, I could count out how many units they were and we'd be fine. But this is for any type, not just horizontal or vertical lines. Now this one can be kind of intimidating because we have this radical here. But if we break it down to the operations that are occurring, we can kind of see the process that goes. Notice we have x1, y1, x2, y2, and we have to plug them in. So the first thing we actually do is we find the difference of the x's and the difference of the y's. Because I'm subtracting x2 from x1, y2 from y1. So I'm subtracting, I'm getting a difference. The next thing I do after that is I square them. Notice the squared that's there. So I'm going to square the differences. After that, I've squared them. I have that plus sign there, so I'm going to add the squares. And that kind of takes care of all the pieces on the inside. So what I'm left with is I'm going to take the square root. So those are our basic operations that we do each time. I give you 2 points. You're going to find the differences of the x's and y's. You're going to square the differences. You add the squares, and then you take the square root. Now let's take a look at this graph real quick and see where distance formula comes from, because it's actually something very familiar for us. If I took a line, any line on a graph, I could, well, any non-horizontal or vertical line, so I could make a triangle out of it. Extend a horizontal line, extend a vertical line, it'll form not only a triangle, but it'll be a right triangle. Now, this segment is AB. But in a right triangle, we could also know it as the hypotenuse. Now, it's a right triangle, so I could call this side a leg, call it leg 1. And this side would be a leg, we'll call it leg 2. Now, you might be recognizing this hypotenuse leg 1 and leg 2 as the hypotenuse squared equals leg squared plus the other leg squared. If that's not looking familiar, what if I wrote it as c squared equals a squared plus b squared? Which, we have problems with using a, b, and c, but for the sake of this, that's Pythagorean theorem. So this Pythagorean theorem that's happening right here is really the distance formula. The distance formula is the Pythagorean theorem in disguise. Because I could keep going, because really that hypotenuse is AB. And then when I look at the leg is the difference of the two values. It's x2 minus x1, and the other leg is y2 minus y1. I substitute that in, they're suddenly squared, and I'm adding them together. I then want to move that squared over AB and take the square root of both sides, and lo and behold, we are at our distance formula. So it's a bit of manipulation from there, but hopefully you see that the distance formula is Pythagorean theorem in disguise. So we're going to do a couple examples, and I'll do mainly the distance formula, but we can also look at how Pythagorean theorem could be a way to solve it. So here's our first one, 2, 3, and 4, negative 1. So I'm going to use just distance, so distance formula. If this is x1, y1, x2, y2, I'm going to say 4 minus 2 squared plus negative 1 minus 3 squared. 4 minus 2 is 2, and then negative 1 minus negative 3, or negative 1 minus 3 we should say, is negative 4. If I square 2 I get 4. If I square negative 4 I get 16, should be positive, and I get the square root of 20. Now I can simplify the square root of 20 because that's 4 times 5, and in simplified radical form we get 2 root 5 units. Now let's look real quick at those operations we did. We said that the differences of the x's, that was 2 and 4, the difference between 2 and 4 is 2. The difference between 3 and negative 1 is 4. And then I had to square them. Well, let's see. 2 squared is 4. 4 squared is 16. Then I had to add them. That's 4 and 16 is 20. And last, I take the square root of both, and I get the square root of 20, which gets us to the same answer. So those steps were there, and you can kind of see how they work in our radical. Now, if I want to graph, so I can hit the axes here. I have 2, 3. And 4, negative 1. I'm going to make a right triangle out of that. And here's my unknown, call it x. And the height of the side is 4. The length of the base is 2. We get x squared equals 2 squared plus 4 squared. X squared equals 4 plus 16. X squared equals 20. Should be looking familiar. I get the square root of 20 as my answer, which simplifies to be 2 root 5. So in all the cases we got the same answer. So it doesn't matter which one you go through, and you're going to notice these patterns that occur with it. Get to the correct distance. So for this next one, I'll just kind of skip through here. I'm going to take the difference of the two. Negative 3 to 1 is 4, so that's going to be 4 squared. And then 2 to negative 4 is 6, that'll be 6 squared. I get 16 plus 36, which is 52. And then 52 is 4 times 13, which is 2 and 2, so we actually can move that down, and we get 2 root 13 units. If we had to approximate square root of 52, 49 we know is 7, 64 we know is 8, so we know it's between 7 and 8, probably a little closer to 7. Last one here, my distance is going to be, my difference on my x's is 4, the difference on my y's is 3. I get 16 and 9 by squaring them, add them together to get 25, and the square root of 25 is 5 units.